Good afternoon and welcome to NHADEC's Lunchtime Connections. The purpose of this webinar is to introduce NHADEC members to one another and give us an opportunity to tell each other about our businesses and capabilities. My name is Stephanie McLaughlin and I will be your host today. I am the principal of Savoir-Faire Marketing Communications, a NHADEC member and a member of the Marketing Committee. The format of today's webinar is as follows. We have three presentations. Each presenter will have approximately 8 minutes to talk about their company. At the end of each presentation, there will be some time for Q&A. You can either ask a question of the presenter directly or type your question into the chat panel and I will pose it to them. To ask a question of the presenter directly, please raise your hand using the software interface and I will call on you. I will be monitoring time and keeping us on track. I may close Q&A if we're running long. Raise your hand in the webinar controls or use the chat panel if you have any questions for me during the webinar. And before we start, one housekeeping item. As this is lunchtime and I anticipate some of you will be eating your lunch during the broadcast, please put yourself on mute. I'd like to introduce Corfin Industries, and today Peter Kielty, the Business Development Director, will be telling us a little bit about Corfin. Welcome, Pete.
Thanks for the introduction, Stephanie. My name is Peter Kielty, again, Manager of Business Development here at Corfin Industries. We're located in Salem, New Hampshire, just over the border from Massachusetts off of Route 93. We've been here at this location for over 25 years. We are about 150 employees and growing steadily. We provide a niche service to the microelectronics market, supporting what's often referred to as mission critical or alternatively as high reliability applications. Applications that fall into that category typically of such urgent nature that failure of those systems could result in life-threatening or loss of life, and they are systems that can be found in defense and aerospace, as well as space, implantable medical, transportation, power infrastructure, and some other smaller market areas. Next slide, please. Next slide. Quick introduction for microelectronic components. What am I referring to? Essentially, if you open up the back of your smartphone, you'd see a slew of very small electronic components. Most folks are familiar with semiconductors. The photo that's depicted here is a more traditional looking semiconductor mounted on a circuit card assembly. It's also surrounded by other electronic devices. Typically, the high-rel marketplace buys these devices commercial off the shelf, so they're not specially designed for the stresses and demands of mission-critical type applications, particularly military, aviation, and space. So what Corfin Industries process does, it's called robotic hot solder dip. It essentially ruggedizes these commercial off-the-shelf components, increasing their reliability and their ability to survive and perform in the very demanding environments they find themselves placed in. Next slide. Not only do we, how do we actually improve the reliability of these devices? When they're manufactured for just commercial use, as a COTS component, there's several aspects of them that make them unsuitable for applications such as defense, and primarily that is that there's the use of pure tin or other lead-free solder alloys, including gold. And I'll talk a little bit why these are a problem and what we do to fix that. But a little bit of background, in the 1940s and beyond, electronic devices were typically produced using a tin lead alloy for their solder use. In the 1980s, the Secretary of Defense released a directive that allowed the Department of Defense to pursue the use of more commercial type products, including electronics. And shortly after that, in the early 2000s, the European Union restricted the use of lead in electronics. That basically led to this changeover to the use of pure tin, so lead was taken out of the mix. Pure tin's an alternative. It works electrically, but it does have some drawbacks. And primarily, it suffers from what is called tin whisker development. I'll show you a photo here in the next slide, but tin whiskers basically are a phenomenon that it's a growth of tin metal that can cause short circuits. And obviously that could adversely affect the functionality of the system. The use of gold plating is another common practice in commercial device manufacturing, and that also causes a problem in its solderability and its ability to stay attached to the boards when they're under high stress. Next slide, please. Tin whiskers. There's a pretty good picture down in the bottom right there, taken through a microscope. It's essentially these random growths of tin that come out of the tin solder. One or more of those contact one another can cause an electrical short circuit. The only way to stop that from happening is to include lead in the solder alloy. Next slide, please. So what do? We basically use our robotic machinery here. We have 18 machines on our operation floor at our site here in Salem that processes literally millions of these electronic components per year and converts them from a pure tin finished state to a tin lead finished state. And then they're returned back to the manufacturer, and they're included in these types of high reliability systems. We became specialists in this field in the early 2000s when we got involved with the U.S. Navy to study this particular manufacturing approach, and this study determined that it is safe for the electronics to be put through this process and provides a stable platform and a reliable electronics platform converted to tin lead. Okay, next slide. That's it. I'll take any questions you might have.
Thanks, Peter. Are there any questions for Pete today?
Yeah, Pete, do component original equipment manufacturers make tin lead finished products for the high reliability market?
Well, they used to. Before these restrictions on the use of lead in Europe, it was typical that the manufacturers of these devices would actually produce them with a tin lead finish. Considering the European market was restricted from that, these commercial manufacturers now have converted to essentially the sole use of pure tin. It's not financially, doesn't make financial sense for them with regards to return on investment to run special lines that make just tin lead parts. Thus, Corfin Industries is here to convert those parts.
Oh, okay, excellent. Thank you.
Thanks, Peter. That's fantastic. We appreciate you joining us today.
Okay, my pleasure. Thank you.
So thanks so much to all our presenters. I sincerely appreciate your time and attention. And if you would like to refer back to this presentation or share it with someone you think might be interested, the video of today's episode will be posted on YouTube and on the NHADEC blog in the coming days. And if you're listening to today's episode and you're interested in being a presenter at an upcoming Lunchtime Connections, please send me an email. My email address is on the screen. It's stephanie@savoirfair-us.com. Thanks so much, and that's it for us today at Lunchtime Connections.